Hi everyone. Good day. Yeah, let's dive into the world of platform APIs in Flutter. Right. Let's simplify that word. Uh, the not so important stuff. Who am I? My name is Samuel Abada. Currently lead the mobile effort at Shortlast Mobility. So yeah, lead mobile engineer, senior mobile engineer. Yeah. Of course, on Twitter, I'm Master Sam underscore. Right? I think so. Then on the GitHub, Master Sound 07. Of course, you can also find me on LinkedIn and whatnot. Yeah, so topic simplifying platform APIs, FFIGen and JNIGen. I think the topic was kind of longer, but on the slide we have to make it appear small so it can fit in easily, right? So we'll take our agenda introduction, looking at Flutter plugins in general, looking at that-only plugins, looking at how FFI is different from platform channels, and how to work with FFIGen and how to work with JNIGen. Of course, at the end of this session, I'm going to provide other resources that we can check out and read them. Of course, it'll be some sample code. Yeah. So first principles. This talk is not to tell you to. It's not to compel you to always use FFIGen or JNIGen for your plugins. No, right? It's just showing you another method by which you can complete platform-specific APIs in a simple way, in a dirty way. Yeah, that's only. So, um, yes. Without further ado, let's dive in. So, generally, right, how do we, when we talk about Flutter plugins, right, we're referring to like packages or small chunk of code that communicates with the native platform, right? So that's how we refer to as plugins. And we say packages are majorly purely that code, right? Well, that's our packages, right? Then we say our plugins are these small chunks of code that help us to communicate with the native code, right? Contains some Java or Kotlin code, Objective C or Swift code, right? Okay, so there are different ways by which we could write plugins. The most common is platform channels. When you think plugins, when you think, oh, how do I do other plugin, right? Off the box, platform channels come to your head using method channels and event channels, right? Of course, there's also Pidgin. Pidgin also exists, to communicate in a type safe way. And FFI is like, I can't say it's like I can't say it's the new guy, but it's still the new guy in this sort of way, right? It's been there for some time, but it's still the new guy among all the options, right? So how are plugins built, right? As a developers, when we think plugin, right, and we think of integrating with the native platform, we think of platform channels. We think, oh, platform channels, right? And platform channels are the usual way for building plugins. There is also the option of using the Pidgin library. But then platform channels require that you have, knowledge of the underlying native platform language. If you're on Android, Java or Objective C. If you're on iOS, that's Swift. No, if you're on Android, sorry, Java or Kotlin. I don't mean. If you're on iOS, Swift or Objective C. On Windows, C++, Mac OS, Objective C, Linux C, right? So that's it. But then the Flutter built-in plugin, the Flutter built-in platform support does not depend on code generation, right? But rather it's some kind of flexible message style, right? That is basically what platform channels are, right? The kind of flexible message style that allows you to send message from the client side or your UI down to the host, right? The host is the native underlying platform, right? So from the client side, you send commands or message to the host, right? That's you send methods to the particular to the host, right? And you go send some other arguments and parameters down to the host. The host is going to perform that command and respond to you with either a success or an error, right? And alternatively, you could use the Pidgin package for sending such structured and type-safe messages, right? So, um, yeah, platform channels are basically a flexible way or a flexible message passing style, right, between the Flutter portion of your app and the non-Dart portion of your app. The non-Dart portion being the native platform of your app, right? Yeah. It's a mechanism that involves sending messages from Flutter to the host, right? Telling it to perform it at a certain logic and expect a particular result, right? Which could be a success or an error response, right? That's basically what platform channels are in general. Okay, so an architectural overview, right, of how platform channels work. So here we have the host, iOS host. Yep. So here we have the iOS host. We have the Android host, of course. Then you have the client, which is the Flutter app, right? So the iOS host, you have the app delegates, Flutter view controller that communicates with third-party APIs for iOS and the iOS platform APIs. We have the Android host, and of course Android activity, the Flutter view. Actually, the Android platform APIs for third-party APIs for Android, right? And then from the Flutter end, the client end, you have your method channel, which is what I mentioned, a flexible message passing style, right? So the Flutter client method channels, then on the iOS end, that's Flutter method channel, and the method channel on the Android end, right? So you pass message from the client to the client to the host, then the host perform the action and send the results back to the client, right? So messages are passed between the UI and the host using platform channels. Everything happens asynchronously, right? And this is to ensure that your app, which is your client side or your UI side, right, is not frozen, right? It remains responsive in doing the process. So, however, a platform channel method is always invoked on the main thread, right? So when you call a channel method, I invoke on the main thread. So, method calls, yeah, basically method calls can happen in reverse, right? Where the platform becomes your client instead of the host. Yeah, right. Yeah, I think that one very good example is quick actions, right? Quick action is just like you could check the quick action plugin on Podder there. I think where you it's like shortcuts where you click on the app icon and you see some other actions you could perform, right? In that case, the platform is the client, right? You've reversed the mode of communication. So let's proceed. Right, so that's basically how regular platform channel plugins, right, behave. But that's only plugins. What are that only plugins, right? So what are that only plugins? Let's see. So what have we said are that only plugins? So we said that only plugins, as the name implies, are plugins written purely in Dart with no native implementation, right? So we say that's only plugins, right? They're not packages, because we say packages are just that code only, no dependence on the native platform, right? But that's only plugins. These are plugins, right? Your regular plugins that depend on native platform. However, they are purely implemented in that with almost no native implementation, right? As opposed to plugins that implement method channels. So that's only plugins are built using the Flutter and that interop with other languages, right? I think they're available everywhere. If you're using FFI, for example, it's available everywhere except the web. I think on the web we have JS interop, right? We have JS interop, so it's still Flutter and that interop, right? Available everywhere, right? But of course, yeah, so that only plugins are built with FFI, which is the foreign function interface, and FFI enables C APIs to be called directly from that, right? So by enabling C API, we're talking about supporting languages that can be compiled to C, things like Rust, Objective C, and C++, right? This is why I said FFI itself is available everywhere, but not the web, because the web natively is JavaScript, right? So we have a separate JS interop for the web, right? So yeah, that's it. Yeah, basically that was FFI basically. I said FFI is short for foreign function interface and it enables C APIs to be used directly from that. Unlike method channels that are called asynchronously, right? I mean, they asynchronously send messages between that and the host on different thread. FFI works on the same thread, right? So when we enable, by enabling C API, we're talking about supporting language that can be converted into C, right? Like Objective-C, Rust, and C++. So yes, earlier I mentioned that for the platform native language for iOS or iOS devices like Swift and Objective-C, it can be compiled to C++, right? To C, right? C++ on Windows compiled down to C. Objective-C on macOS can be compiled down to C. C on Linux, C is C, right? Which is why I said FFI available everywhere but the web. The web is JS native, so that's JS interop. Okay, let's proceed. So how are that only plugins different from irregular platform channel or platform meta channel plugins, right? How are the two approach different? Number one, type safety, right? With FFI or JNIGen, type safety is maintained. Seems we've not touched JNI itself. So JNI stands for Java Native Interface, right? It's basically an interface that allows Java code that's run inside a JVM to interface with other applications and libraries that are written in other languages, Objective-C, C++, C, and assembly, right? And as such, it's similar to FFI, right? It's basically the same, I call it foreign function interface. I mean, but then yeah. So as a library, right? JNI exists to support access to the JNI from that of Flutter code and provide a common infrastructure to binding generated by JNIGen. When I say a library, I mean JNI itself is available as a package on pub.dev, right? So it's a library, right, that exists to support you having access to the Java native interface JNI itself from that of Flutter code, right? And then your JNI generator, right, needs the JNI package itself, right? So this JNI itself provides a common infrastructure to the bindings that will be generated by the JNIGen. Okay, now that we've touched FFI and JNI, I think we can proceed. Yes. So how are the two approaches different? Taking the FFI/JNI approach and the platform channel approach. Firstly, type safety, right? With JNI and FFI, right, your type safety is maintained. You don't do unnecessary cast. And why do we do unnecessary cast? It's because somewhere down the line we've lost track of the type, right? It's very simple, right? I mentioned earlier we established that by doing method channels, you're basically communicating, right, or sending message in a flexible way, right? So that means I send the command and I send some kind of argument or data, right? So if I send a string, an int, a string, or whatever, right? That process of carrying the communication from the client side down to the host, right? The type gets lost. It's why inside the host you still have to do some kind of type casting again. Right? It's why when you look at certain Flutter plugins that use meta channel, you see that on the host end, right, or the native end, they do some type casting, right? When they return back to if it returns a value back to the client, you feel that they have to do some kind of type casting there, right? And of course, you see people open issues on having plugins where they tell you that they try using this plugin, but it threw this error, right? And yeah, some of these errors are. And when you look at some of those errors, they're basically a type-related issue, right? A wrong cast actually happened somewhere, right? Or the type mismatch. So yeah, with FFI and JNI, you maintain type safety. Secondly, FFI and JNI, right? It's a DAT API. It depends on that, right? So in theory, there should be no dependence on the Flutter engine. I mean, yeah, it's a DAT API, so there should be no dependence on the Flutter engine, right? So yeah, I use in theory because it could happen, but I've not really seen it happen, right? Yes. It's more performance. They interact with the native component directly, and they do that on the same thread, right? So Yes. The way they communicate with native code, right? Plugins that communicate directly with system library and native APIs will not necessarily carry native code. Yes, that's straightforward. This implies that if the plugin is going to communicate with the native system library or system API, I don't have to carry any native code because we're going to generate a that client, right, for that native library or native code, and that basically provide me a one-to-one matching of the methods. So if native code has 10 methods, I might be getting 10 methods with actually the same name, right? Yeah. Complexity. FFI introduces code complexity, and this is like one, should I say, disadvantage now or limitation, right? The foreign function interface introduces code complexity, which can be managed by the FFI and GNI Gen 2, right? So FFI and GNI is code generation, right? You don't need to know what's going to happen under the hood. However, if you're interested, you could, look it up, and I mean, it's open source, it's available out there, you can read it. But then that code complexity is not managed by you, it's done by the FFI and JNIGen 2, so you don't need to worry about the code complexity. Okay. Yeah, so working with FFIGen, how do we work with FFIGen? Working with FFIGen, basically starting, I think it's on 3 or 4 steps now, if I remember right. But we'll look at those steps one by one. So, using FFI adds some level of code complexity. However, package FFIGen exists to manage this complexity. Using FFIGen to create a plugin involves adding the FFI to dependency and FFIGen as native as dev dependency, right? You have to create a top level FFI configuration and run the FFIGen to generate the necessary bindings. This FFIGen will generate you a Dart API/client, which is more or less a one-to-one mapping of the method available for the native API. Hence, you can call the native API directly in Dart. This also means you can read the native API doc as a guide, since the methods are mapped one-to-one, right? So if I look at the API doc, the native doc, and it says call this method, call this method, call this method, right? I can follow, right? I can create a mental model of that step or process, and follow with the code generated by the FFIGen, because I'm using similar method, same method, right? So I know, oh, I'm calling this method, calling this method, calling this method. So one-to-one mapping, straightforward. So the process, first things first, you have to add the required dependencies. So we add the package FFI as a dependency and FFIGen itself as a dev dependency. After that, we create a config file. The config file is a top level FFIGen.yaml file, right? By top level, we mean it's kept in the project's root of your project. Then we generate the necessary bindings by running FFIGen, right, to generate the necessary C and that binding. Then the last thing is using the bindings. You load the dy_lib, right, and then instantiate the library. Then the library ready to use. Like that, these are basically the 4 steps. Any other thing, you just have to read and follow the docs religiously, right? I mean, the docs are like the single source of, are like source of truths, are like our Bible, or yeah. So yeah. So this is what a sample FFIGen YAML looks like. FFI config file. Right? This is copied from the Flutter. I think it's Flutter. It's available as an example in the Flutter repo. But I've attached the link to the resources available in the slide. So this is what it looks like. Name pedometer binding. I think this is a sample project created called pedometer, right? It's like a step counter. Yeah, I think it uses Health Connect on Android, if I remember correctly. So pedometer bindings, binding for C and pedometer, the language Objective-C. This output tells it where to output the generated Dart version, the Dart API or the Dart client, right? Then the compiler options, it passes there, exclude all by default true, objective interface, include, these are the whatever interfaces that we need, right? And then set the header entry points, right? So this was your FFI config file looks like. Then we run flutter pub run FFIGen config FFIGen.yaml, and yeah, of course, it creates the necessary files that needs to be created. I mentioned earlier that FFI is a dat API. So by a dat API, you can also run it by doing dat run, instead of flutter pub, you can use dat instead. So I mean, a dat API, and then it works in Flutter also, because Flutter depends on dat. Dat is the language, so but it works. So that's FFIGen. Then for JNIGen, it's similar, right? The JNI itself adds some level of code complexity. However, package JNIGen exists to manage this complexity. Using JNIGen to create a plugin involves adding JNI and JNIGen as dependencies, creating a top-level JNI configuration, and running the JNIGen to generate the necessary bindings. So the JNIGen itself generates a dat or API client similar to the FFIGen, which is more or less a one-to-one mapping of the method available to the native API. Hence, you can call the native API directly in that, right? This, by implication, this means you can read the native API docs, create a meta model of the process you take, and then do the same in that, since the methods are already mapped one-to-one. However, there are cases where the methods may not be mapped one-to-one. A very good example is method overloading. We know Java supports method overloading. That is, a method, you can have a method with multiple implementation and different arguments. Take, for example, a method that says add numbers, right? I could have 4 different methods with that same name, add numbers. What is different is basically the arguments, right? So method overloading, Java supports that. So how does the JNIGen attend to this? What JNIGen does is append a number to the method name, right? So if the method, let's call it method A, right? If it has 4 different implementations, method A, then somebody else take method A, right? What the JNI does is append a number to each of them, right? So when it generates method A, the first one, it does method A1, second one method A2, third one method A3, then method A4. So that's how this works, right? So that way you're able to still you can still follow your documentation, and yeah. So let's see, working with JNIGen to generating the dat bindings or whatever bindings, right? The first step is to add the dependency. You add package JNI as a dependency and package JNIGen as a dev dependency, right? Then of course you have to pub get. Then secondly, you create a top level YAML config file called JNIGen.yaml. You generate the bindings by running JNIGen to generate the necessary C and dat bindings. Of course, you have to modify your app build as Gradle and to include the section called external native build, right? This is basically to include the generated CMake file now to your build as Gradle. Those are basically the first steps, right? That's like the first step, working with JNIGen. Then you can start using the generated dat client. Any other thing is to consult the documentation. I mean, the documentation is the truth. Okay. So here's what a sample config JNIGen looks like, right? So this also is from that same pedometer repo available. I think it's from the Flutter theme itself. A sample, an example project, right? Add Gradle dependency true. Add Gradle sources true. The Android the project is in the example folder. Then suspend font assist. This means this suspension function. I think it's called suspension function now. I can't remember. Yeah, I think it's suspend functions, right? Convert them to asynchronous functions in that. So suspend functions to asynchronous true, right? Then the output, we need the output file should be kept in src/ health connect, right? The library name is health connect, like the C output. However, for the that end, right, we kept it a live slash health connect dot that. So this and the structure is a single file, right? So basically, what I've told it here to do is, hey, so help me generate the necessary generate a dart client for this. The dart client should be kept in the file live slash health connect dot that as a single file, where the associated C files should be generated and kept in the path src slash health connect. The library name should be called health connect, right? And then, of course, I've shortened the classes that were called or that were used just for brevity's sake, so that I can fit it all in the slide. Yeah, so we have, you add whatever classes you want to add, right? And that's it. That's how JNI works. So we have the JNI YAML, you do flutter pub run JNIGen config JNIGen.yaml. I mentioned earlier that FFI and JNI, they are that APIs, right? So you can also do that run instead, right? Well, of course, this is for a Flutter app, so Flutter pub run JNIGen. And yes, I mentioned, I think the last step was to add the external native build, right, section to your app build Gradle, and this is what we have here. You can see I have external native build, the CMake, right, the path to the CMake. If you notice that in the CIF, we mentioned earlier, right, that the output, the C output should be in the path src health connect. Library name is health connect. So inside that same src, it will generate you the CMake file itself.txt, right? So we've added the CMake part here. src health connect CMake list.txt, right? Once again, this is available as an example in the Flutter repo. I think the project is called pedometer. You could check this out and play with it just to see how it works, right? I think I think there are other plugins that use FFI and JNI. I think that's like Win32, which is FFI, if I remember correctly. I think there's the Camera X plugin that yeah. So basically, this is how you work with FFI and JNIGen, and then every other thing is as simple as importing the Dart client, right, and using it in your code. The same way you use the same way you call any other Dart class or Dart code, right? So yes, that's it basically. This talk is not exactly a deep dive into JNI and FFI and how it works under the hood and the company project, right? Usually to create the awareness that we could build native Flutter plugins, right, with native capabilities, and put that in quotes, right, using FFI and JNI, a simplified way of building Flutter plugins, leveraging that interops. The longer one can, okay, yeah, leveraging that interops. So yeah, keep learning. These are other resources you could check. Taking that interops with Android from the Flutter team, using FFI in a Flutter plugin, it's a code lab. Java interop using package JNIGen. This is available. I think this is a link to the Java interop documentation from the that team, that of Flutter. I can't remember exactly. Then, of course, the example project FFI plus JNI pedometer from the Flutter team. Then you could also check out Renan talk at, I think it's Flutter Connection now, all right? The World of That Only plugins. Yeah, I think he did a live demo, right, on how this works. So yes, thank you so much. My name remains Samuel Abada, and yeah, I'm available everywhere. Not everywhere, technically, exactly. Twitter as MasterSlam _ GitHub as MasterSlam07. You can check me out on LinkedIn as Samuel Abada, and yeah, so see you next time. Yeah, and keep learning. Bye.